Okay, hello everybody. Good afternoon. I'm going to go ahead and get started here. So I wanted to talk to you guys about our week 7 homework. And I wanted to talk to you about a couple other things. One, noticing to recognize good code and how to recognize bad code also. And also I'm going to talk about how to clean up our code and structure it a little bit better. And hopefully you guys will be able to use some of these techniques moving forward with all of your projects that you're doing. So this is the solution that I got from Trilogy for homework week 7. So you can see here, basically the logic of this is that it uses jQuery together with Firebase to do a bunch of stuff. They set up a Firebase data architecture, which basically has a game. I can show you here in the Firebase console, actually. Basically, what it does is there's one table for chats, and then there's another table for players when players join the game. So let's go ahead and play the game here, and I can show you guys sort of how it works. Well, what I want to show you guys first, though, is how I refactored this code. So I don't know if any of you had a chance to take a look. I sent out last night the link to the Wikipedia article on code smells. So I'm just going to pull this up here real quick. So we can see it, Wikipedia says, in computer programming, code smell or bad smell is any symptom in the code source or program that possibly indicates a deeper problem. According to Martin Fowler, who's a computer scientist, a code smell is a surface indication that usually corresponds to a deeper problem in the system. Another way to look at code smells is with respect to the principles and quality. Smells are certain structures in the code that indicate violation or fundamental design principles and negative impact in design. Code smells are usually not bugs. They are not technically incorrect and do not prevent the program from functioning. Instead, they indicate weaknesses in design that may be slowing down development and increasing the risk of bugs or failures in the future. Bad code smells can be an indicator of factors that contribute to technical debt. And technical debt is a very important thing that you'll run into as you're learning to program. It basically means that the things we don't clean up and do the right way now, we'll have to save and do them again later. And if we don't, we're going to run into all kinds of problems in our code. So let's take a look at this code from Trilogy. And let's see if we can see any of the technical debt, any of the code smells. So 3 of the code smells that I would like all of you to familiarize yourselves with for this are inconsistency, redundancy, repetition, inconsistency, redundancy, and the last one I want you guys to look for is too long. There are several others, but these are good to get us started for now. So if we go back to this code from Trilogy, we can see, first of all, this file itself is way too long. So that is definitely one problem. Also, it's very hard to read. There are if statements nested inside of if statements here, which makes it very hard to read and sort of figure out what's going on. The jQuery is mixed in with the Firebase database calls, which also makes it hard to read. Everything is kind of jumbled together. So what I did was I went ahead and refactored a lot of this code and put it into, pulled it out into nice little functions, kind of the way that I was showing you guys with the other game that we did with the Hangman game. So let me show you what this looks like. Okay, so here is the refactored code. What I did is I went in here to this solution that we got from Trilogy, and basically anytime I saw a repetition, like here, we can see that we're doing the same thing here on these 3 lines of code as we are here in these 3 lines of code, and these 3 lines of code are doing the same thing as these 3 lines of code, except we're doing it for player 1 or for player 2. So the only thing that's changing is player 1 or player 2. So anytime I saw an instance of repetition like that, I pulled it out and made it its own function. So by doing that, by pulling everything out into a small function, naming it, I got rid of all of the anonymous functions that we're passing in here as callbacks. Close some of these extra windows I'm not using. So you can see I made this whole thing much simpler. Now, as I pulled out several of these functions, a pattern began to emerge. That pattern is that some of these functions are here to update things, are here to basically handle eventualities, like to listen for events, or to handle things like when a new player gets added, to handle when there's a new turn, to handle when there's a win, to handle when the username gets submitted. So these things are all handlers. So I organized them all into their own section. The next thing is there are a few functions that were just for game logic, so I put them all together in their own section. Then there are several things that we're going to do that are just updating the UI. So I put all of these things together. These functions all start with update, and they go in their own section for UI updates. Then some things are going to be updating things in the database. So these are database updater functions. So you can see this code is a lot clearer and easier to read now that we have everything broken up into nice little bite-sized pieces, nice little chunks of Legos. So it's just a lot easier to read, a lot easier to manage, a lot easier to update than going back to this here, the code we initially got from Trilogy. Is everyone seeing how this is working? Any questions on this so far? Wait, are you guys not able to see this? Is everyone able to see my screen? I'm just going to stop till I get some feedback here. The logo. I don't know it. Can you hear my voice? It should be working. Okay. Hey, Melvin.
Hey, John, I don't know if you can hear me.
Yeah, I can hear you. Can you hear me?
Oh, yeah, I can.
Okay, cool. Okay, so did you catch any of that, what I just showed you guys, or no? No.
No,
Okay.
I didn't see anything you went over right now.
Okay, so I'll start again from the beginning. Basically, what I was showing was how I refactored the solution for the homework. This is the homework code that I got from Trilogy. So just looking at it, you can see that there are a lot of things wrong with it. There's a lot of code smell. So what I just went over is this whole concept of code smell in Wikipedia. Basically what it is. So you guys can go ahead and read this article. It just says a code smell is a symptom in the source code of a program that indicates a deeper problem. So it's something about the way a program's coded that shows you that there might be something wrong with it because there's either inconsistency or it's too long or it's repetitive or something like that. So yeah, so you can go ahead and read about code smells on your own. The ones that I wanted you guys to know about for now are these here. Inconsistency, redundancy, repetition, and too long. So we can see several of these if we go and look at the code from Trilogy. You can see that they're passing in anonymous callback functions to many of these things. We have jQuery mixed in with the Firebase code, so everything's kind of mushed together. There are if statements nested within inside of if statements. It's very hard to kind of tell what everything does. Everything kind of just runs on and is jumbled together. So what I did was I tried to go through and refactor this and pull everything out and make it into nice little functions because I saw a lot of repetition and a lot of redundancy. Like here, we're highlighting the border for player 2. Here, we're highlighting the border for player 1, but it's pretty much the same thing. Here, we're setting the turn. Here, we're also setting the other player's turn. So what I did was I went and copied all of these things and broke them out into their own little functions. Which is what we can see, sorry, here. So basically I went through and broke everything up into nice bite-sized little pieces, nice little chunks of Legos, kind of similar to what I showed you guys that we did on the Hangman game. So basically none of these functions are too long. They all do exactly one thing. And that's all I basically did. I just broke everything out into functions that do one thing. If I saw a function where I could encapsulate a pattern, like if we were updating player 1 and also player 2, I made that into one function, and then you just pass in an ID, say for the player. So I went through and did this with pretty much all of the code and just kind of straightened it out and made it nicer. As I did this, a sort of pattern began to emerge. What I began to see is there were some functions that basically handled events or eventualities, like when a player joins the game, when a player takes their turn, when a player submits their name, when a player submits a chat, all of that. You have these little functions to handle things when one thing happens. And these are the functions that we're passing into the event handlers for the callback functions, both for the database events and for the jQuery events. Then we have another section of functions here that just handles the game logic. So these functions basically just handle the game. I made it a lot simpler from the code from Trilogy. For them, they actually have an if statement with 8 different blocks, one for each different combination of rock, paper, or scissors. In my version, I made it a little bit simpler. Whereas Pedro suggested in class, we basically just need to do this. We need to see if the one that comes next comes before the one that comes before it, and we just keep looping around. So rock comes before paper, so therefore paper beats rock. Scissors comes before rock, so therefore rock beats scissors. So we can just use this logic here to basically check who wins the game, or we can just check if the two equal each other to see if there's a tie, which we do here. So I made the logic a little bit simpler, and basically I broke it out into these 3 functions that handle the game logic. Then you have a bunch of functions that handle the jQuery stuff and update things in the UI. So I broke those out into their own section for the UI functions. And then you have several functions that actually send things to the database. Then there are a few utility functions that basically get things from the form. You're either going to validate the form, you're going to get a form field value, or you're going to reset the form. There are a few global variables on top. So hopefully this is making sense to you so far, how I sort of refactored all of this and how it's working. I can show you what the next step I was working on was, and then you can sort of see me live code it because I'm halfway through. So I know in previous classes we had talked about ways to structure the code in a modular sort of way, which would make everything a bit easier to read and manage. Like, let's say I wanted to break each one of these things out into their own modules. I wanted to have all of the data functions in their own module. I wanted to have all of the UI functions in their own modules, and then I wanted to have all of the handlers in their own modules. And that way I have a nice sort of architecture where things all work together nicely and it's very clean and easy to read. So that is sort of what I was working on here. And the way I did it was by using an open source library called Require.js. So what Require.js does is it just gives you a nice, easy way to basically encapsulate your modules so that you can use them together. So it basically lets us sort of chunk all of our Lego pieces together so that we can attach them together easily without having any problems. JavaScript was never intended to be used as a sort of object-oriented or modular language, really, so we have to add a little bit of syntactic sugar on top in order to make it work. So you can go to the Require.js website and take a look at what it does. I would recommend that all of you use these for your projects that you're working on now, because it will make them structured a lot better and make everything easier to work with. So here's the Require.js website. Basically, the way it works is that certain modules will have dependencies on certain other modules. So I broke it out. So I have one module for the database. And this just basically has all of the database functions in it. Some of these functions will be public, some of them will be private, meaning that some of them will need to be used outside of this module. So that's why those get set to a this.function name here, whereas the private variables and methods just get set with a var. So hopefully that makes sense so far. So I broke up all of my database functions into a database module. I just declared on top by using the define function of require. And then I have my UI class here. I'm going to define jQuery and just passing in jQuery. The UI module is the only module that needs to use jQuery, so I'm just passing it in. And I can show you the way that I'm doing that here. Basically, this is the app.js, so this is going to be like the root script file that controls all the other script files. So in here, we have a Require.js config, which basically configures the other libraries that I'm going to be using with my Require.js application. And in this case, it's going to be jQuery and Bootstrap. So I'm just giving it a path, basically, to where jQuery is in my, or on the CDN, and then I can require it in the modules that use it. In this case, the only module that uses it is the UI module. So in addition to DB and UI modules, I also have my handlers module. The handlers, as we talked about, handles all of the high-level logic when events happen, when things happen in the game, etc. So handlers pulls in DB and UI as a dependency. So basically, the pattern that has emerged here is that you have handlers that talk to the database and to the UI, and then that basically provides an abstraction layer. So that way we don't have to have database code and UI code together, because that makes it a lot harder to deal with. This is a pattern that is pretty common in software development, and a lot of times it is referred to as model view controller, meaning that your data is a model. Then the way that you're showing it is going to be a view. Then you have some logic for how you want to show the data from the database in your view. So you handle that logic in the controller. So it's a way of separating your app into 3 nice segmented layers, so that way all of your logic isn't all pushed together into one thing. Hopefully that makes sense. So a few other notes on Require.js. When you are including Require.js in your HTML file, you just do it like this. You don't have to put a link to your app.js or any of your own JavaScript files. You do it in this data main data attribute on the script tag for Require.js itself. So here in my data main data attribute, I'm putting the path to my app.js scripts/app. You don't have to put the .js. That is inferred. So that way it knows to load my app.js. So let's go ahead and try to load this here and see what happens. And then you guys can stay with me as I continue to debug this and get everything working. Okay. So we can see here that chat data is not defined. So basically, before I started doing this screen share, I was working on breaking everything up into this modular architecture, but I still hadn't quite finished yet. So some problems with this is that the DB module and the UI module are supposed to split out the database and the UI, so we don't talk to the database and the UI directly. We talk to them through our database and UI module. So that just makes the code a bit cleaner. So in order to facilitate that, I'm going to make this form that we're listening for the submit event on to be a property of my UI object. And we'll just call it username form. And then in my UI module, I'll just go ahead and define this dot username form equals that. And then we'll do the same thing here. We'll call this one chat form. So it's going to be UI.chat form. What's that? Go to my
John, do you mind if I interrupt you for a second?
Sure.
Okay, I understand what you're trying to do at the moment. You're trying to clean up the code based on whatever they had originally written from Trilogy. And I understand the value and importance of that. My concern at the moment, though, is that it's not exactly my primary concern with trying to complete the assignment.
Okay, got you. This is the way I'm going to show you guys how to do it because it's important that you start practicing writing clean code now. So if you're going to be able to get through this next project that you're working on, if you're going to get through all of your projects, it's important that you learn to write clean modular code. That's why I was going to show you guys how to do it this way, because it will be a lot easier for you to figure out how to do it sort of in a clean type of way. And then what I was going to do is I was going to give you guys out some of the code and just have you clean it up and make it more modular. And so I think that's the best thing to do to get you guys on a good path to learning and becoming good developers, is learning to write this kind of clean modular code. Does that make sense?
It makes sense. I have my own reservations on it, but I understand where you're coming from.
Yeah. Well, what are your reservations?
Given that we're still trying to get there, well, I personally am still trying to get my head around the database writing, which I've gotten a better understanding on all these trial and errors I've been doing. Maybe kind of like portion it off at 2 different times. Like I don't know how much more difficult it would be, but perhaps code the game initially and then break it off into segments, although I understand that's a large order to do it that way.
We already have it coded, though, is the thing, Melvin. So we have this here is like all of the code. So basically, I already went over this. I can go over it again. We have form utilities. We know that we're going to need to do 3 things from the form. We know that we're going to need to validate the form to see if the only thing that we're really checking for is that the chat field and that the username field both have a value. That's thing number 1. Thing number 2 is we need to get a field from either one of the forms. Could be the chat form, could be the username form. The other thing is that we're going to need to reset both of these forms. So we have a function to reset the forms. Then we have our set of database setters. So we're going to need to set our player data to be these global variables. And this just gets from our snapshot object. that gets passed in. We get the first child, we get the second child. These work with the database structure that we have, which basically adds a new user every time a user enters. So we're calling this set player data function from the callback function that gets fired here. Oh no, I'm sorry, we're calling set player data. Yeah, we're calling it when a new player gets pushed, and we're calling handle player push when the player ref event listener gets fired, when a new player gets added. So as you can see, there's just a few other database functions that we have to send things to the database. We're going to need to send a message when a message gets sent. When the chat form gets submitted, we're going to need to send the choice that they chose. When they choose rock, paper, or scissors, we're going to need to send that choice to the database. We're going to need to send the database a new player when a new player joins the game. We're going to need to send the database their turn. We are going to need to get a reference to the chat for the database, which we use. We're going to need to send a disconnected message on disconnect. We're going to need to send a signal to the database that we're starting the game by setting the current turn in the database. Then you have UI functions. You can pretty much just believe me when I say this updates stuff in the UI. You're going to need to update the player's info. When a player joins, you're going to need to update the chat box when we join the chat. You need to just update a bunch of things in the UI. You're going to need to update them when you're waiting for a player. You have a bunch of eventualities that you need to update for in the UI. Then you just have your game logic, which, as I said, is very simple. You just loop around the array and check to see if it's the next thing. This is the algorithm to see who won if there isn't a tie. And we're just checking for that here. We pass in A or B. It's either 1, 0, 1, or 2. We pass that into the check game function. And then we just call our handle win function and pass in which player won and the data for that player. And it tells you that they won through our UI functions. Then you have a bunch of handlers, which basically handle the events, both the events from the database and the events from the UI. So we have handle error, handle user choice, handle chat disconnect, handle chat push, handle username submit, handle chat submit, handle player push, handle turn push. This is when we add a new turn to the database. This is kind of the more complicated logic in the game. There's still more if statements than I would like, although I cleaned it up a lot. You can see the Trilogy version was way more confusing, I think. Yeah, so I cleaned it up a lot. All that we're really doing here in this function is we're saying if the player hasn't joined the game yet, we're going to return. If the current turn is greater than 2, that means the game is already full. The way this database architecture is architected, you can only have 2 people playing the game at one time. You can't have multiple games going on concurrently, which is not the way I designed it, but that's the way this was done. So if there's more than 2 people already in the game, then you're going to say, hey, you can't join the game now. There are already too many people. Or no, I'm sorry. First, we check to see if the turn is greater than 2. If the turn is 0, then it's player 1's turn. If the turn is 1, it's player 1's turn. If the turn is 2, it's player 2's turn. If it's 3, then the game is over. In this case, we go and run the game logic and check to see who won, and then update that to the database and let the users know through the UI. If there is no current turn, then we're waiting for the player to join. So then we run the UI update and just update our UI to let them know that we're waiting for a player to join. Then if both players are there, we're going to highlight the player whose current turn it is. And by the way, these returns tell it to quit after every one thing. So if there's no player number, we're going to quit. If the current number is greater than 2, we're going to run this game logic function with these parameters that I'm passing in, and then we're going to quit. If there is no current turn, we're going to run the function to update the UI to let the user know that we're waiting for the other user to join. Then we're going to quit. If none of this is true, then that means that both players are there, so we can go ahead and highlight the player whose turn it is. Then, if the current turn equals the player number, then that means it's your turn. It means it's the current player's turn, so then we're going to show them the rock, paper, or scissors option so they can click on them. Otherwise, it's the other player's turn, so we're going to use our jQuery to update the UI to tell the other player that we're waiting for them to choose. And we're just using a little ternary expression here to check and see if the other player is player number 1 or player number 2, and then we're going to show their name. Then we just have some logic here to handle what happens when somebody wins. It just shows you which player wins, basically. And then here at the bottom, we just have our event listeners for our form submit, our event listeners for our on-click, for the choices, rock, paper, or scissors. Then these last 4 event listeners are event listeners to listen for things to happen in the database. This first one is to listen for new chats to get added to the database. The second one tracks changes in key. So basically, this checks to see when the player goes, this fires, and or when a new player gets added, this fires, and we use our handler to handle a new player. Then when there's a new turn, we use this event handler to handle the new turn. When we start the game, we use this event handler to send the start of the game message to the database. Does that make sense, Melvin?
Sorry, I had the mic muted. As far as what you've been breaking down, yeah. Personally, it kind of feels a little bit more like if I was an auto plant worker and I'm trying to build the cars, I'm at the part trying to figure out how to arm the pieces together, and not so much trying to figure out what pieces do I actually have present in front of me, if that makes any sense.
Yeah, you're looking at the low-level stuff when I'm kind of showing you more at a high level.
Okay, okay.
And that's good that you're seeing it that way, but you want to look at the high level, even though at this point it's going to be kind of painful for you because you don't know, you're like, wait, how do I do this? I want to do things this way, the way they're sort of showing you here, where we have everything kind of jumbled together, where we have all of our anonymous functions passed into our event listeners and everything is kind of jumbled together. Nothing's really labeled. So it's kind of hard to see what everything does. If you think about this more from an architectural perspective, more from a high-level perspective of, okay, we're going to have some things we're going to need to update in the UI. Then we're going to have other things we're going to need to do in the database. Then we're going to need to have ways of managing how these things work together, right? So you basically have these 3 things. These are the patterns that are starting to show up. We update things in our UI, we update things in the database, and then we handle things changing in the UI and go and update things in the database. We handle things changing in the database and then go and update them in the UI. So this is sort of the pattern that's emerging. And we're trying to encapsulate that in logic. And this is the best kind of way to solve these kind of problems. Even if it seems kind of daunting at first, it's better to at first think of the high level architecture of, okay, what are the things I'm going to have to update in the UI? What are the things I'm going to have to update in the database? How are these things going to work together? Does that make sense?
Yeah, that makes sense, because if I were to go over what I originally pseudocoded, there was a lack of, I still could have gone a further level higher in how to organize it, because I only listed what I saw present in the video. I didn't understand at the time and therefore didn't do it. How the database would have to be written to and read from in order to actually implement those changes. So along the lines of what you're saying,
you have to write to the database, and then you have to listen for changes to the database and do things when it changes. You have to do those 2 things.
Right. So it's kind of just to piggyback on what you were saying, that to think it at a high level. My pseudocoding, I thought was at a high level, but I guess it still needed to go one higher level further before I could have actually continued the assignment in the way I was doing it.
Yeah, and there's a lot to do here, and you have pretty limited time. So I would use this code that I'm showing you as a guide. And then if anything, try to structure it. I would be more interested to see you guys learn to structure these things together at a high level, learn to use something like require.js. What I was showing you, just take this code and make it work with require.js. I think that would be better for your development right now than just to kind of bang on it and get it to work. Because we know we can bang on it and get it to work. The question is, can we make it scalable? Can we make it able to grow and something we can actually use versus like a one-off kind of thing that we're not going to want to look at again?
Okay. Yeah, it makes sense.
So with this, or the way I was showing you here with it modular, it would be very easy to add features. Like if I wanted to add authentication, say, if I wanted to add any new feature, I would just go right here. If it's something we're adding to the UI, I would go here to my UI. I would add a new function to my UI to do whatever that thing is, and then I would just link to it. If I am doing it in this kind of an architecture here, where everything is jumbled together, sort of, then it's much harder to figure out where to change stuff and how to make it grow.
Okay, I can see what you're trying to accomplish with that. And if we have the project, then it's just that's due after this one. It's a good step to have established.
That's exactly what I was thinking. I want you guys to get in the habit of doing things the right way so that you can make projects that are scalable, that can grow, that will be easy to work on with your other partners. So that if you have it done this way, you could say, hey, maybe somebody work on the UI that's better with jQuery stuff. Maybe if there's somebody on your team that's better with Firebase, they'll work on the database side of things. They'll be working.
Sorry. That just kind of hit me because we were talking about that last night in my group about, okay, I'm like one person slightly better at the APIs than in the Firebase. But if we were to have to keep this on one singular JavaScript file, that would be a little bit difficult to divvy up the task.
Right. So if you break up your logic into all the different things, the UI, the database, the handlers that talk to the UI in the database, then you can have different people working on different files. So it makes it work together a lot better. It makes it a lot better to update things, to change things, to allow your software to continue to grow without kind of getting tangled up. So that's why we're learning to do it this way.
Okay. From that, I guess, I know you're still in the middle of actually going through this presentation, so forgive me if I'm jumping the gun here, but from there, it's just pretty much the Firebase portion that I was still trying to get implemented because I was working on the assignment before you started the video, and the part I was lost on, like speaking to one of the TAs last night, I was just I better understood a piece I was failing to understand that database needs to read and write select portions, but not all portions of it. So yeah, as far as what you're going over, I understand what you're doing. I appreciate it, and I'm in better agreement now than I was about 10 minutes ago when you first started.
Yeah.
It's just the database portion I still need more help on.
Don't get too attached to the in the weed stuff, like, oh no, I can't figure out how to get the database to work, because you will. That stuff is out there, and it's just a matter of finding the right answers that you need. And you will find those things. But if you have the high-level architecture, then you can at least know what you need to know. So you can say, hey, I know I'm going to need to send a message to the database. I know there's going to be a time when someone wants to send a message, and I'm going to want to push that message up to the database, right? So you could just make this send message function. It doesn't even really matter what's inside it yet. This in here is your implementation, right? This is your interface, your high-level logic. The database send message. So as long as you know you have to send a message, you can just go through and fill in the blanks in here later. You can go on Firebase documentation and say, how do I push something?
Oh, okay. Okay, now I see you. So it's like pseudocoding part 2, per se.
Yeah, it's like a higher level of pseudocoding. You pseudocode out the high level, and then you go and figure out all the little implementation details. And because we have nice little functions that only do one thing, you can go in here and just figure out, hey, what's this one thing I need to do? I just need to figure out how to send a message with Firebase. That's only one thing to figure out how to do. So that's pretty easy to go and look that up and figure it out. If you have all of this stuff jumbled together, like this, you have to figure out how do I make a huge jumble of mess, which isn't a question you can ask on Google or figure out. So it's a lot more trickier to get it to this kind of a point because it's all jumbled together.
Okay, now I'm on the same page as you are. Okay.
Yeah, so that's why I'm a pretty high-level guy. I like to focus on the high-level stuff. As far as we can talk a little bit about how this database stuff is working, though, as well. So basically, the way this works, as you know, we have our database config. This is just the information that needs to connect to Firebase. Then we run the Firebase.initialize. All right, with me so far?
Yeah, with you so far.
Then we set up these references. The first one is to the database. We just call the .database method on Firebase. This gives us database. Then we have our chat data. We get this by using the .ref method on the database. We just created and we pass in /chat. So this gives us the chat property of our root object in Firebase.
Wouldn't it be chat slash, or does that part not matter so much?
It's /chat. This is what I got from the solutions.
Oh, okay. Because for what I was implementing, I was doing the chat then the slash. I don't. So far for the pieces I did get working, it was going okay. That's why I was just checking.
Yeah, I think the /chat, you need the slash because it's separate from everything else.
Oh, okay.
I tried it this way with the slash beforehand. I'm not exactly even sure why they needed it that way. I just refactored all the code from the code they had working. So then you have a reference to your player's object, and then you have a reference to your turn property, which is just a number 1, 2, or 3. So you have these 3 things. This is the way they had their database set up. It isn't necessarily the way I would have done it. I probably would have done it in a more scalable way so you could have multiple concurrent games. And you would do that by basically having an array or a collection of users, and then you have an array or a collection of games. And when the game is finished, you just save it. And that way you'll have that data for later. If you want to, say, get the high scores of all the players or something, you can do that. If you wanted to add authentication, say, that would be very easy to do, etc. So that's the way, if I were going to start doing it from scratch, I would design the database slightly differently than I did, or than it is now. But the way it is now, there's basically just one concurrent game, and it will add the 2 players, player 1 and player 2, and then it adds the 2 choices, and then you compare the 2 choices. Okay. And then you see we just know we need to send these certain things. We know we need to send a chat disconnect message. We know we need to send a turn update message. We know we need to send a new player message. We know we need to send a message when they choose rock, paper, or scissors, etc. So I can show you, if you want this thing working. Then, as you saw with this app, we have our UI functions, which just update the UI to let people know basically what's going on. Are we still waiting for the other player? Did the other player choose rock? You know, all that kind of stuff.
Okay.
And then you understand the handlers part, right? This sort of handles the high-level logic for when things happen, for when something gets written to the database, for when somebody clicks on something, all of the logic for our games going here. These are what are typically called the controllers, or the controller layer of our application, the logic layer.
Sort of. Let me see. So your handlers are just the parts that are like the event listeners, basically, right?
Yeah, they're the event listeners, exactly.
Okay, and in there you would be able to implement scripts from both the DB.js and the UI.js?
Right, so this basically so this is the way it works. The handlers talk to the database in the UI, and then they go back and talk to our app. So that way we don't have to be mixing the 2 things together in our high-level logic. Because it gets messy when you have UI functions and database functions all mixed together. That's a very common problem programmers run into, where they try to basically just jumble everything together, the things that you need to show in the UI and the things that you need to set in the database. So it makes things a lot easier and a lot cleaner when you separate these 2 things. So you have one layer that's your database, one layer that's your view or your UI, and then one layer that's your controller that basically controls everything.
And then if, so those 3 are separate, and then the 3 culminate into the app.js, because that way you only have to have your HTML reference one JS file?
Yes, that's the way I have this one set up now here personally, but the pattern that I'm talking about on a broader scope is just model view controller. So you separate it into three things. You have your UI view, then you have your database model, and then you have your controllers, which handle the logic. So it basically separates everything out into three nice layers. The way I have it set up now, it's using app.js. But that's just the way it made sense to me to do it this one time. Does that make sense?
Let me just give it a quick glance at what you have on the screen on the app.js.
Yeah, so on app.js, all I really have is the event listeners. All I wanted to put in app.js were the event listeners. I could actually have my handlers be the app.js, but I just wanted to split it up into more different modules so that none of the modules get too long, basically. I could also have made another module for my form utilities and just call that form util or something.
Okay.
So basically, you want to, anytime you have like a distinct group of things that your functions are doing, you want to split your code up so that your functions are very small and do only one thing, right? You shouldn't have lots of logic jumbled together, jQuery to update the UI somewhere and then update the database somewhere and then, you know, do a lot of stuff together. You should have nice little small functions, nice little chunks of Lego pieces that you can easily stick together that do one thing. Then when you do things this way, this pattern will start to emerge where you get functions that do similar things and you can group them together and then you can put them together into modules.
Okay. High level, I understand it. It's just a little bit of connecting the pieces together, but I get where you're going with it.
Right, and that's normal. You should have that. And it's good that you're here actually to play devil's advocate because I'm sure the rest of the class probably has these same kind of questions. But when you guys start working on your projects, you will kind of need to do things this way. Otherwise, it will just turn into a big mess. So that's why I thought it was important to get you guys going with this clean way of doing things now.
No, and I understand that. If I'm playing devil's advocate for the class, I think everyone's still a little bit more concerned about getting this assignment done. But yeah. I know we're focusing on the long game here.
Yeah, we're focusing on the long game. I mean, these assignments are basically just busy work. They didn't even do the greatest job on getting it done. So I'm a lot more worried about you guys learning to write code the right way. I mean, you'll learn to get this stuff done. If you don't learn to make a Firebase project now, you'll figure it out later. And I'll make this code available to you, and you guys can sort of choose your own level of involvement with how much you want to copy and how much you want to try to write yourself and how much you want to use it as a guide, etc. You know what I mean? So you can use the code that I'm giving you as a guide to answer all those sort of questions that you have, probably about what you're doing wrong with Firebase. Does that work for you?
Yeah, it doesn't beat having someone there right next to you, but then again, that's not exactly an option we had on the table beforehand anyway.
Yeah, it's not really an option that you have, and it's good to get used to doing these things yourself anyway. And I'm showing you guys here basically what you have to do in order to code this. You have your UI functions, you have your database functions, and you have your event handler functions. You have those three things. You need to figure out which ones you'll need. There are about 7 or 8 of each that you need to figure out which ones you want. You can see them all here in the code. You need to handle when a new player gets pushed. You need to handle when a chat gets submitted. You need to handle when a username gets submitted. You need to handle when the chat gets disconnected. You need to handle when the user chooses, etc. So you just have to figure out what all of these eventualities are. And then you just need to figure out the little blocks of code to handle them.
Okay. It's a lot better than where I was before, I guess.
Yeah, and you're doing it in the right way. You're doing it in a structured way, which makes a lot more sense. So I can show you, we only have 10 minutes left. I am going to show you, I guess I didn't have time to show you how I would refactor things into Require.js, but you didn't seem as interested in that anyway. So let me show you how this whole app is working together with just the refactored version I have here. So I am going to copy this and make a new file here. Okay. And then our index, we'll just go ahead and copy this out. And then I just need jQuery. Actually, here's what I can do.
Bye.
While we're on the subject, is the Require.js one of the new technologies we can use for our projects if we wanted?
Yes, absolutely, and I would highly recommend it. I was going to say that. I would recommend that being your new technology that you use, or one of them at least.
Okay.
So, okay, so let's see if this works the way I did it now with the old script that doesn't have require. So you can see we have a bunch of messages here. We have somebody named Fru. Okay, so let's see what the error is. Any errors? No. So let's see. You can type hello. So it looks like my event listeners are not working. We have jQuery, we have Apple.js. Oh, shoot. This is the wrong old version. This is the one I refactored. So let's do this. Okay. So it's going to ask me for player 2 to choose. We're waiting for player 2. Or paper. Scissors. Oh, it doesn't say which one won, but I guess it's this one. Player 2 wins. I gotta fix that UI updater to say who won. But this is basically how it works. I can type in some stuff here. Shows up over here. Type it in over here. And it shows up over here. So this is pretty complicated, but if you break it down into the different types of logical functions, like separating the database functions from the UI functions from the controller functions that are used as event callbacks, if you basically break it up into those three things, that's the sort of secret to getting everything a lot simpler. So you can, depending on which one is easiest for you to think about, you can either think about all of the UI updates first, think about the requirements for it, go over and read the instructions again, look at your requirements, then think about what are all of the updates that I'll have to make to the UI? What are all of the updates that I'll have to make to the database? What are all of the events that I'll have to listen for on the database? And what are all of the events that I'll have to listen for on the UI? Once you figure out those four things, you pretty much have everything you need to build it out. And from there, it's just going and figuring out how to fill in the blanks, which is all mostly like Googling for stuff. So I get it. I mean, I know it seems kind of complicated, but it isn't when you break it down into small little bite-sized steps.
Okay, and for the event handler, for trying to figure out the portion of the events and the handlers, any changes or any events that need to be monitored for both the database and the UI can be stored within the handlers.js.
Yeah, that can both go within your handlers class because they both handle things, because they'll need to talk to things. Like when you submit a form, it will need to update things in the UI and in the database. Usually when something happens in the database, like you push a new user, you need to update stuff in the UI. And sometimes even update more stuff in the database as well. So I think this pattern that I've found works well. You have all of the event handlers together, the event handlers for the database and the event handlers for the UI, because they sort of work the same way. So the handlers sort of serves as a buffer between the database and the UI, if that makes any sense.
A little bit. I'd have to go over it, but I get on a high level what it ends up doing.
Yeah, you get why it ends up doing, and you get why it's sort of bad, right? To have everything jumbled together, to have your database code sort of jumbled together with your UI code and everything together. It just makes it harder to read. It's harder to update. It's less maintainable, less scalable, all that good stuff.
Yeah, with that part I can agree with, because basically what I have coded right now in my JavaScript is essentially trying to get two pairs to register, and even with that snippet of the code, it still got kind of confusing differentiating between, oh, this variable is the one from the database and that one is the one for the HTML, and this one's the JavaScript, so forth. So yeah, I see the benefit in doing it this way.
Yeah,
it's just a matter of, like you said, figuring out the other portions of the database, as you put it, the digging in the weeds.
Yeah, that's the in the weeds part. But you want to separate them out, because if you get the in the weeds part and the high level logic part jumbled together, then you'll never get it untangled and figured out. If you have them as two distinct things, then it's pretty easy to go sort of step by step and methodically kind of get everything straightened out.
Okay.
So let me show you just what the database looks like too, because that might be helpful for you as well. So this is what happens here after we play our game. The turn goes to turn number 3. And then there's supposed to be a reset function in my script, which I haven't added yet, but was in the solution. I just haven't copied it over from the solution to my code. So when the game is over, it's supposed to automatically reset the game. I haven't added that part yet, but this is basically how it works. You have your one collection for your chat messages, right? So these are all just the different chat messages I've sent. Then there's another collection for players. So there can never be more than 2 players at any one time. If there are, it just tells you it's full, right? And then it can count the wins and the losses for each of these players, because it will reset. When it resets the game, it just resets the turn, but it doesn't reset the players. And then it also listens for an on disconnect event, because Firebase, in addition to having like database push events, there's also an on disconnect event that it listens for. I can show you in my app.js. That's probably the cleanest video here. So we are listening for disconnect events as well. The place that we're doing it is actually where we set up the chat. So you can see here we're sending a message to show that we've disconnected. Where am I disconnecting from this? See, so here we have chatref.onDisconnect. So this is saying when somebody disconnects from the chat, then send this message. Yeah, I think that's it. Does this make sense, Melvin?
Yeah, just a matter of going through it like anything else, trial and error.
Yeah, I mean, there's going to be some trial and error. You're learning a new skill. I think doing it in this kind of way, learning to separate out the logic into database logic, UI logic, and then controller logic that basically combines the two is the best way to do it, though. So I think this should be a good first step, and hopefully you can use this code, which I'll send out to you, and get it all sort of straightened out.
Okay, thank you. I do appreciate that.
Yeah, no problem. And I mean, we have plenty of other opportunities to practice too, so keep that in mind. So if you don't get this one perfect, it's not the end of the world. I'd rather honestly have you focus on your team projects for right now, and that's one of the reasons I wanted to have you guys do this, so you didn't get kind of too stuck in the weeds with all of this stuff.
No, and we're also on the same page. The rest of the class doesn't want to focus too much time on this assignment when the deadline for the project is so close. We just realized that, well, we were more concerned that given the difficulty we were having with utilizing Firebase with this assignment, regardless of whether it's the rock, paper, scissors or the train schedule, we were going to have some more difficulties trying to get along with the project, missing that particular piece of the puzzle.
Yeah, so just think of it this way. Think of it like just you want to architect it out on a high level. Firebase will work for you. It's not like Firebase is broken and it doesn't work. It will do these things for you, and there's just a matter of finding out how that it does them. So if you architect your application, so you say, okay, I'm going to send this thing to Firebase, and then I'm going to listen for something to get added to Firebase and do something when the database gets updated. If you can figure out how that logic works at a high level and write out the functions for it, you're like 75% or more of the way there already. Because then you just have to go and read the Firebase documentation and say, hey, how do I listen for this event? Or you can come and ask me or ask one of the TAs, you know what I mean? Or there's a whole lot of different ways you could figure that out. If you're trying to figure out how to do 5 different things at once and they're all kind of meshed together, then it's going to be a lot harder to get you to the right answer.
Yeah, that part I can agree on, because just trying to start, I was like, okay, when the new player, I'm thinking the new player needs to add here, which needs to update the Firebase, and so forth and so on. So the detangling portion, I completely agree with.
Right. Yeah. So I thought this was important. I'm going to send out this file. Any other questions or questions on the homework you're working on now? If there's anything that you couldn't figure out.
Jonathan.
Yeah. Hey, Nelson. How's it going?
How you doing? Sorry, because I joined late. Can you show me really quick which was the event handler that you were using for letting the application know when the other user is joining the game?
Oh, joining the game? So that was the push. Hold on, sorry. Let me go back. So handle player push. So we have in our database, let me show you the database thing. We have this collection of players, right? 1 or 2. So we're going to push when you first were listening to see the username form submit. So when the username submits when the user submits the username form, it fires a callback, and event handlers handle username submit. Username submit. So when the new username gets submitted, we validate the form. We show an error if there is no username. Then we capitalize it. Then we call this get in game function. What the get in game function does is it basically puts them in the game. So it sets an event listener for the on disconnect event for when if they disconnect, it will remove them. And then we finally send a chat disconnect message if they've disconnected.
This on disconnect function is a built-in function, or is one function that you define?
The on disconnect is a built-in function of Fire.
Okay.
Yeah, so I'm trying to see oh yeah, so we're sending the new player here. So by running this new db.sendPlayer function, I have that in my db class. Send new player. So what this does is it writes the new player to the database. So the user comes in, he enters his username in the form. It does a bunch of stuff. It updates the UI, then it comes to this database class, and then it does this to update the Firebase database, right? We have a reference to our database, to this part of the database, the players, and then the right player number. So there's player number 1, then player number 2. So we know which player number it is that we're going to add because we know if there already was a player there or not. Does that make sense? So yeah, so we're gonna, based on which player is already there, it's gonna be either player number 1 or player number 2. So that's what this here is doing. It's players slash, and then it's gonna be either /1 or /2, depending on if it's player 1 or player 2. Then we just use this ref.set to set the Firebase database, and then we return the ref because we're gonna need to use it for something later in order to add on the disconnect message.
Wait, what does the return part do again?
So the return part returns the reference because I also need to add this on disconnect event listener. So we need to listen for the on disconnect. If when the person leaves the game, we're supposed to remove them from the game.
Okay.
Does that make sense?
No, sorry, I didn't catch that.
Okay, so like this part hasn't even been completely working for me. I don't think it works in the example. But the idea behind it is that Firebase gives you this on disconnect event that fires when somebody leaves, right? So say you have a player that's on who's supposed to be playing rock, paper, scissors with you. He's trying to decide which one he wants to choose. And then all of a sudden he just leaves the game without choosing. This is supposed to notice that and then notify you of that.
Okay. Yeah.
So we'll remove the player, and then you can even handle that eventuality. Like you can do something like show a message that said, hey, your player just quit, and then restart the game.
Okay, yeah, that part I understood. It was just what you said about the return function that I wasn't entirely clear on.
Yeah, that part is separate. So the way this is working is I have this player ref variable that I'm declaring. I'm setting it to equal db.sendNewPlayerUsername. So that goes over here to my database class and send new player because I'm sending it to the database. So that's why I call it send. So send new player. So I define this variable ref. Then I do ref.set. This sends the new data to the database. Then I return this reference because I'm going to need it again. What I'm going to need it for is to add the on disconnect method to it.
Only 2 people can play the game at the same time. Let's say another 2 people wants to join in a different game. That's gonna cause an error, right?
That won't work with this particular architecture. The way this developer architected the game, it won't work. So the way. Yeah, so I can show you the way that I would have designed it so that it would work if you want to see. Basically what I'm going to be doing, I will just show you guys the JSON structure. Since Firebase is a JSON store, I'll just show you what the JSON structure would be for this. So you have 2 things. You have users, and that's a collection of objects, and then you have games, and that is a collection of objects. So say we add a new user, your user could have a bunch of information about him, his first name, his last name, and then we could even link it to the authentication platform that is part of Firebase too. So we would have like name, for now, we'll just give them name, right? So name John, and then I could say wins 1 or something if we wanted to do this. So then games, be a collection. And so you would add a new game. The game would have like a
player 1 and player 2, maybe.
Yeah, player 1 choice. That's all it would really need is like a player 1 choice and a player 2 choice. So you can tell you don't really need all the logic that they have implemented for whose turn is it, all these different things, because you can just tell if the other person has gone, then it's your turn to go. And both people can go at the same time. You don't really need to wait for the other person. You just don't show the result until they're both back. Right? Does that make sense?
Yes.
Right.
So yeah, so that's all you would have. You would have your collection of users and then your collection of games. And then inside the game, you would basically just have player 1. And then you would have a link to the player 1 object because each of your objects in Firebase gets its own foreign key. As you can see here, everything gets its own foreign key, like with these chats. So you would put a reference in the games collection to the foreign key for the users collection. Does that make sense?
That's the way we reference another object in the database, right?
Yeah. So if have you ever worked with SQL or anything, Nelson?
Yes, I work with SQL.
Okay, so it's the same way. So you know how foreign keys work then. So
Okay.
the same thing. You're just going to provide the foreign key.
Okay.
So you would have player one would be an object, and you would have like choice. Could be in this version, they're using the string rock, paper, or scissors. I would prefer to just represent it as 0, 1, or 2. 0 is rock, 1 is paper, 2 is scissors. So you have the choice and then the foreign key to the user object. Make sense?
And we cannot reference directly to the object name. For example, if we want to reference one object, like saying users dot something.
If you want to reference, you can.
No, yeah. I need the foreign key. Sorry. I was thinking. I need the foreign key anyway. Yes.
Yeah, you need to use the foreign key for that. You can do that. You just use the foreign.
Yes, because there's a bunch of them inside, and I don't know which one is the specific one I'm looking for.
But to piggyback on what Nelson was saying, I was having a little difficulty trying to figure out how to reference a specific child of any just any specific child in the database.
You have to keep that key.
Yeah, you have to use the key, and then you use the slashes in order to do it. Here, I can show you some examples of where we've done it.
For example, if you assign that key to
like
the data,
say I'm trying to reference the first player under the player array. That's what I was having trouble referencing. And then within that player one, reference the name.
Wait, so let's take a look at our database schema. If you're trying to get player one and then the name.
Yes, like if I was trying to draw out that specific information.
Okay, let me show you. So, see, it would be players database.ref players / and then the player number 1, and then .child choice. So this would be, if you wanted name, you would make this name. Does that make sense?
In that case, the foreign key for players is number 1 and number 2, right?
That's the way this is structured now. The way that I was showing you that I thought would be a better way would not be 1 or 2. That's not a foreign key. That's just a 1 or a 2. That's a unique identifier. The foreign keys are the longer things that you see like here. These are what the foreign keys actually.
Yeah. Okay. Yeah, but in that case, the developer of the exercise made it 1 and 2 instead of that number.
Yeah, I think they should have done it the other way instead, because it's not scalable this way. You couldn't link like authentication to it. You couldn't give somebody a profile. You couldn't make it store persistent data in a browser, like if you wanted to store a cookie. So it would say welcome back, Nelson, instead of, you know what I mean, instead of asking you every time. So it's very hard to make it scalable to add new features to it. So
I understand what you're saying.
Yeah, so I think that's why this architecture that I showed you here is better. You just have a collection of users and then a collection of games. And if the game is over, you just go to the next game and keep adding the games to the database, and you don't throw anything away. Because then you can use that data later if you want to, say, calculate high scores or something. You can do that as well.
Okay.
Does that make sense?
Yes.
Okay.
Thank you.
Okay. Any other questions, guys?
Nothing that we have enough time for, but when you flag out the file, I can have a better idea what to do.
Yeah, sorry. So this was a very difficult assignment. I thought the way that it was solved for you guys was very hard to understand. So I would rather get you guys thinking about how to develop things kind of modularly, how to write clean code, how to learn about code smells. I recommend that everyone goes and reads that Wikipedia article on code smells. Learn what to look for with code smells and learn how to avoid them, and learn how to start writing clean, maintainable code now, and it will come in handy in the future.
Okay, so we won't get penalized too harshly if we don't exactly have a whole lot to submit, will we?
No, just submit what you have as always, and my preference is that you guys work on your team projects. So if you don't have that much, or you tried and you're like 75% there, just submit it. At the very least, we can always give you a chance to like redo it later, or, you know, just do what you can. It won't be the end of the world. The priority is the group project stuff.
All right, because I was only gonna try to finish whatever I could tonight anyway. So because I know the project's more important.
Yeah, perfect. Just finish whatever you can tonight. I'm giving you guys what I did so you can, like I say, choose your own level of involvement in basically how much you want to reference that, how much you want to lean on that. That's entirely up to you. Okay.
Okay, but if what we submit this time around isn't it as compartmentalized as you have it in this presentation, for this particular instance, it's not that big of a deal. But moving forward, it's something we should try to implement or should implement.
You should try to implement. And you guys don't get graded on code at all. You just get graded on functionality. That's the way it's set up. But yes, moving forward, it's something you should try to implement. You should try to use Require.js in your group project and try to split it up as I showed you into sort of a model view controller. Kind of a setup where you have your things that do stuff with the UI, you have your things that do stuff with the database. You'll probably want to make a new module for each API that you're connecting to with your projects as well.
Okay.
So like say you're using OMDB, let's just say, then you would make a new module for OMDB and all of the things that you do from OMDB, whether it's getting movie titles or getting actors or whatever, you would make a new method for that in your OMDB module that
Okay.
with React.js. Okay?
All right. Thank you very much for the time, John. I appreciate it.
No problem.
Thank you.
See you guys tomorrow. Bye.
Bye.